don't. It's confidential. All right, home plate for today, pages 352 to 353, number 7 through 17. All right, we got to go. I told you guys today's going to be a doozy, so everybody go like this. Bear with me, because it's going to go really fast. So fast, I'm going to be like... All right. Here we go. Our objective for today, I can simplify exponential and radical expressions. Let me repeat that again. I can simplify exponential and radical expressions. So, like I said, yesterday was a practice for you guys to get all the basic skills that you needed for what's coming up today. Now, I'm assured that all of you, being my students, you did your practice. Thank you very much. Appreciate it. All right, here we go. We know what exponential expressions are. We don't need a prayer model for that. We filled one of these in yesterday. Okay. From there, I said anytime you see a number without an exponent, you always write a 1, because today's going to go a lot faster. If you're not doing that by now, you're going to start making mistakes. Whenever you see a variable without a 1, put a 1 on the exponent. Same thing with any negatives. We talked about commutative and associative property. You're doing that in your noodle, so I don't need to see the work. From there, we covered the properties of multiplication, and we covered the properties of division. Yes? Then we did some practice, yada, yada, yada. And then for home play, you guys did something like this. Yeah? And for home play, you had some problems that were left with fractions, which is fine. But today, we're going to find out how to simplify those fractions. So like that, we don't have any answers with an exponent that has a fraction. Yes? What's that? How do I do D? All right. So, any questions with the properties from yesterday? We good? All right, good. Today, fill out your prayer model. Radical expressions, what are they? They are an expression containing a radical symbol. There it is. So from now on, anytime that you're dictating to me or you're telling me what the expression is, I don't want to hear you say square root of whatever with a little number outside. Okay? I'm going to give you proper terminology. Okay? But whenever you see this symbol, from now on, it's what? Radical. Well, if you want to be like a surfer, radical, dude. Yeah? All right, examples. This one is a square root of 90, but you would say radical 90. This one is square root of 8 over x, or we would say radical 8 over x. Okay? According to the definition for radical expressions, it's an expression. Are these expressions? Yes. Do they have a radical symbol? Yes. Non-examples. Look at this one and look at that one. Tell your neighbor why these are not radical expressions. All right, let's see. Damien, why is this one not a radical? It doesn't have a radical. How about this one? It's an equation. We're still not there. We are headed there, but this one's a radical equation. All right. So, what makes a radical expression a radical expression? There's only 2 hashtags that you should have. Don't say it out loud. Write them down. What are 2 things that make a radical expression a radical expression? All right. Tell your neighbor. All right. Looks like Chance is on the ball today. He's a radical symbol and expressions. Yep. Extra credit, Chance. All right, so we got that. So, once again, reminder. Any questions with this? All right, y'all ready? Okay, like I said, hold on to your horses. Here we go. Writing utensils down, look up to the screen. I'm going to go over some processes that we've been doing from the beginning of the school year on the warm-ups. By now, this should be on our frontal lobe called the short-term memory by now. I brought them back from the long-term to the short-term because we've been practicing these on the warm-up. Here it goes. On the warm-ups, I gave you stuff like this, x to the 1/2. And I said, rewrite it. Oh, okay, that is radical x. On the same token, if I was to write x to the 1/3, I can rewrite that as radical x, but with a number here outside. Some of you just say with a little number outside. This number from now on, remember it as the index. Index, that's the proper term. Once again, radical and index. Therefore, if I was to write x to the 1/4, tell your neighbor what we would write. Okay, once again, we're not saying square root anymore, right? We're saying x with a radical and the index of 4. All right? Now, I said don't copy those, but copy this next one. X to the 1/a. Rewrite that, please. All right, tell your neighbor whether you were right. All right, so we wrote what? Radical x with an index of a. Any questions with that process? We good? All right, writing utensils down. Here goes the next part. This is all stuff that you need to remember. This is stuff that you should know by now, and it should be automatic. Next, focus, please. In the past, we've done stuff like that. Square root of x squared. And obviously, some of you are like, oh, cancel the square, cancel the square root, and this becomes x. Why? I don't know. You told us, Mr. Q. All right. Let me give you the process one more time. Square root means what number times itself 2 times equals to x squared. Oh, that's x times x. Also, the number is x. That's why. Therefore, if I was to write cube root of x cubed, what number times itself, how many times now? 3 give us x cubed. X times x times x, that gives us x cubed, so this is x. So far, so good? All right, but what if I had this? Cube root of x to the 6. Don't say it out loud. What number times itself 3 times give us x to the 6? Talk it over to your neighbor, please. What number times itself 3 times gives x to the 6? All right, let's see. Pao, what did your neighbor say? X squared. Let's see. The base is x. Let's see. Yes, yes, yes. So then you're thinking, since we're multiplying, I need to add the exponents. What exponent goes here, here, and here that I can add them to give me 6? Let's see. 1 plus 1 plus 1 is 3. So it's 2, 2, and 2. Is that 6? Yes. So my number is x squared. Hold on. Next. Cube root of x to the 15. Don't say it out loud. Tell your neighbor. All right, let's see. What'd you get, Javier? X to the 5th power. Hands if you agree. That is correct, because x to the 5th times x to the 5th, x to the 15. Now, check this out. We did this before. Those of you who were with me in Algebra 1, by now this should be familiar. And you're like, yeah, I remember these, Mr. Q. However, I said, I'm going to show you guys a shortcut when we did this as a property. And I showed you this. Look up. Tell your neighbor the property, please. What is it doing?
Divide.
What's dividing?
The index and
The exponent divided by the index. That would be the shortcut. So like that, you don't have to break your brain thinking like, what number times it's? Oh, okay. Well, there you go. Copy this last one. And as you're copying that, do this next one by yourself. Fourth root of x to the 400. All right, tell your neighbor what you got for this one, please. All right, let's see. What you get for this one? Chloe. X to the what? 100. Hands, have you got that? Yeah, we got this, yes?
Yeah.
All right. But I know some of you in your noodle, some of you, not all of you, but some of you are asking yourself, Mr. Q, I get it because I see that 15 is a multiple of 3, 6 is a multiple of 3, 400 is a multiple of 4, and that's why it works. What if it was not a multiple of that index? Think about it. We can't do it, right? We'll end up with a fraction if we divide. So there's one way of simplifying by rewriting this. Check this out. What number is close to 7 that's a multiple of 3? 6. So I would write x to the 6 times x to the first. Cube root. We no longer need this one. Therefore, 6 divided by 3, x squared. What's left? Cube root of x. Copy that. And as you're doing that one, I'm going to give you one more. Fourth root of x to the 13. See what you do. Keep it to yourself. Let people struggle a little bit with it and see what they get. All right, here we go. 13 is not a multiple of 4. However, let's see. Chloe, pick someone. Josh, what's a number close to 13 that's a multiple of 4? 12, so this would be x to the 12 times x to the first. We no longer use that one. 4 through to that. So what is 12 divided by 4? X to the third. We no longer use that. What's left? 4th root of x. And have you got that? Okay, we got this, yes? All right. Next. So this is all, what? Something to remember, okay? This is still not part of the lesson yet. I'm just giving you stuff to refresh your memory. We already did some of this. I'm just trying to give you and build you up to where we're going. Copy this. 27 to the 2/3. Unite. All right. Once again, when we got to exponential expressions, when we covered Algebra 1, we got to these, and they had like a little trick to them, if you want to call it. But it's not a trick because it's all mathematics. So look up. Writing utensils down, look up. Who notices that now we have a fraction, but this one has a numerator greater than 1? You guys see that right here? All right. So check this out. I need to rewrite this. Why, Mr. Q? Because I know that anything to the 1/3 power is what? Cube root of whatever. Is that correct? So I need to make this look like that. So check this out. I'm going to write it big over here, this exponent big over here. 2/3 can be rewritten as 1/3 times 2. Let's see, let me go backwards. What is 2 times 1? 2 and over 3. Does everybody agree with that so far? Okay. So if that's true, I'm going to rewrite this. You're just paying attention. I'm going to change color so that you see that I rewrote this. 27 to the 1/3 times 2. All right. So now that I have this, 27 to the 1/3. What's another way of writing a multiplication other than a dot? Parentheses. To the 2nd power. What is 27 to the 1/3? That's cube root of 27. To the what? 2nd power. What is cube root of 27? 3, bring down the 2nd power, and that is 9. Copy that, please.
The whole thing?
No, just this. Oh, except the something to remember. There you go. Now, mind you, all these little components that I'm giving you, they're like 1, 2, I've given you so far 1, 2, 3, 4, about 4 little puzzle pieces. At the end, we're going to put it all together in one problem. Okay? Yay! Fun-er. That's my word. All right, here we go. You already copied this. I want you to simplify this next one. How about 8 to the 4/3? I'm going to change to blue to rewrite it. Let's see. Who went last? Josh? Pass someone? Leo. How do I rewrite this? That is correct. 8 to the 1/3 times 4. All right. And then from there, I have 8 to the 1/3. And what I do? In parentheses to the what? 4th power. That's someone, Leo? Perla. How do I rewrite 8 to the 1/3? Okay. 3 radical 8. Parentheses to the 4th. All right. So Perla, what number times itself 3 times give us 8? 2. And all that to the 4th power. What does that mean? It means 2 times 2 times 2 times 2. So that means this is 16. And have you got that? Okay. Yeah, we got this, yes? All right. Y'all ready? Okay. All right. So before we get into the main part, I need one more component before we get started. Here we go. Last thing. Look up. And we're still where? Chance? All right. Last thing to remember. Check this out. Cube root of, what is it? Okay, 24. Check this out. Relax, pay attention, please. You're going to need this skill for what's coming, all right? Here goes. What number times itself 3 times give us 24? I don't know. There is none. 1 times 1 times 1? No. 2 times 3, 3 times 6 times 2? No. 4 times 4 times. So, what I need to do is go back to elementary stuff and do this. Okay, kids, today we're going to make a factor tree. Here we go. What's our first prime number? 2. 24 divided by 2 is 12. Okay, how about the 12? 2, that's 6. How about 6? 2, that's 3. These are 2 primes, okay? So what are these prime factors? Why factors? Because if we multiply them, it's going to give us 24 again. So now that I have my prime factors, I can rewrite this as exponential expressions. This becomes 2, how many of them? 3 times 3. You see this? 2 to the third and 1 3. And all that to the cube root. And now, can we simplify? What is 3 divided by 3? 1. So we're left with 2 to the first. We're done with it. What's left inside? Cube root of 3. Copy that, please. It is. All right. We good? Okay, so those are the skills that we should have, that it should be pretty automatic, and some of you are like, this is kind of rusty, Mr. Q, but I think with practice, I think I got it, right? All right, let's go to the properties for today. Properties for today. We have multiplication and division properties of radicals. So I'm only going to give you 2, okay? And that's all you're going to need. Here we go. First property, multiplication, says cube root of x times cube root of y. Let's see what we have. We have an expression, another expression. They're both radicals and they have the same index. Do you guys notice that? When you multiply 2 expressions or radical expressions that have the same index, we can rewrite it as 1 and multiply the radicand, or the numbers inside. So this becomes cube root of x times y. That only works if they have the same index. And if they don't, then you cannot put them together. You just leave them as is. Let's try with numbers. Cube root of 2 times cube root of 3. What would you get? Don't say it out loud. That becomes cube root of, what is 2 times 3? 6. Now I'm going to do the converse. No, I'm not talking about shoes. I'm talking about the converse, which means going backwards. So watch. If I start with cube root of AB. How can I rewrite that? Cube root of A times cube root of B. Oh, sorry. B. I did that to see if you're paying attention. And of course, with numbers, cube root of 6. Factors of 6, Leo. One and 6, or what are my prime factors? 2 times 3, okay. And how do I rewrite that? Cube root of 2 times cube root of 3. Okay, that's multiplication. Division. We got square root of x divided by y. We can split that up and make it square root of x over square root of y. However, can we leave a radical in the denominator? No, so I need to multiply times square root of y times square root of y. Now some of you are saying, why, Mr. Q? So look up really quick. The radical is going to cancel a what inside? A squared, is that correct? So if we have y to the first power, we need to multiply times y to the first power so that we can get radical y to the second power, and then the next step we cancel the square root and the square. Does that make sense? Yes, Mr. Q. Numerator, square root of xy. So we're left with square root of xy over y. This cancels out. Using numbers, square root of 25 over 64. Do that one by yourself. Copy that and go. All right, let's see what you get. Mr. Q, bam, let's go. Square root of 25 over square root of 64. What is square root of 25? 5. Square root of 64, 8. And I'm done. Yeah? Okay, show me your feelings. How comfortable are with these properties? Yeah, 5s, right? How comfortable are you with the something to remember part? 4 5s, 4 5s, yes? We just need practice, right? Let's put it together. Ready? Here we go. Example 8. Example 8 reads, simplify. Cube root of 256 x cubed y to the 7th. Guys, and it looks more funner than what it is. You'll see right now, okay? So here we go. Let's do the first step together. Look at it. We have a radical to the 3rd. So this is cube root of all this. So in order for it not to be so much, I'm going to split it up into 3 radicals. Why 3? Because we have a number, we have an x value, and we have a y value. So how can I write it? I'm going to do it in blue. Cube root of 256 times what? Cube root of x cubed, that is correct, times cube root of y to the 7th. So now if we focus just on each one individually, didn't we do all that practice earlier with each piece? Yes. So let's start with the number. Okay, here we go. What number times itself 3 times gives me 256? I don't know, Mr. Q. All right. Therefore, can we divide by 2? Let's see. 2, yeah, that's 128. Can we divide by 2? Yeah, that's 64. Can we divide by 2? Yeah, that's 32. Can we divide by 2? Yeah, that's 16. Divide by 2, yeah, that's 8. Divide by 2 and 4. 2 and 2. So let's see, how many 2's do we have? 1, 2, 3, 4, 5, 6, 7, 8. So we write it as cube root of 2 to the 8. Does this look familiar? Let's see. What was the shortcut? Divide that by that. But is it a multiple of 3? What number's closer to 8 that's a multiple of 3? But we can't add to it. We can only split it up. 6. So this becomes 2 to the 6 times 2 to the 2nd. And we're going to take the what? The cube root. Now we do the division. What is 6 divided by 3? 2, so we're left with 2 to the 2nd. We no longer need this. What's left inside? That. So I write cube root of 2 to the second. Yeah, it's simple. It's just work. Now let's see. One more step. What is 2 to the 2nd? 4 cube root of, which is 4. Now we have it to the lowest terms. There it is. So we're done with the number. Let's go back up and let's go to the next one. Let's see. I'm going to switch to red. Can we divide 3 by 3? Yeah, so that leaves us with x to the first. So we're done, and we bring that one down. Bring it down and put that times x to the first. All right, are we done? No, we have one more radical. What is it? The y. Is 7 a multiple of 3? No, so we need to rewrite this. This becomes what? Y to the what? 6 times y to the first cube root. So let's see. What is 6 divided by 3? 2, so that's y to the second. We're done with this. That leaves us with cube root of y to the first. And we bring that down here. Times y to the second cube root of y to the first. We brought this down over here. One last step. Here we go. Look at it. Look at all the factors that are outside a radical. Underline them. The 4. What else? X to the first. And what else? Y to the second. So we need to write those together by themselves. So we get 4 x to the first, y to the second. Okay. Now look. Look up. What do we have left? This one and this one. Can we put them together? Do they have the same index? Can we put them as 1? Yes, this becomes what? Cube root of 4y. And we're done. You see how all the other little pieces came together? Yeah. Let me zoom out. Look at that. Humor. Down. How we doing? On the back? No, I like it in the front. All right, here we go. Before I give you one for you to practice, I want to go to the division part. This was what? Multiplication. Let's go to division. Copy this one. Example 8 cubed. Now you guys see why you needed to practice last night doing your home play? Really? Let me see. Pretty flexible to me. All right. Can we rewrite this? Yes. Fourth root of 81 over fourth root of x. Okay. So, next. This one, do we need to do a factor tree, or can we think of a number times itself 4 times that gives me 81? 3, that is correct. 3 times 3 is 9. 3 times 3 is 9. 9 times 9, 81. There it is. Okay, I bring this over. Fourth root of x. However, we cannot leave the denominator with a radical. That means we need to multiply times fourth root of something times top and bottom. Now, here's the part where some get confused. Look up. On the next step over here, I need to get fourth roots of x to the fourth in order to cancel these. Is that correct? So, question. What number times x to the first gives me x to the fourth? X to the third. So we need to multiply top and bottom times fourth root of x to the third. So what do we have in the numerator now? 3 fourth root of x to the third. And at the denominator I have fourth root of x to the fourth. So the next step we just simplify. This is 3 fourth root of x to the third. This cancels that, and we're left with x. All right, now, instead of giving you one all the way from the beginning, this is where I lose some of you. So I'm going to give you one that's not related to this one, but I'm going to start it from about right here so that you can show me what to multiply to simplify. Okay, here we go. Copy this. 5 over cube root of x. So the next step, we need to multiply top and bottom times cube root of something. In order to get, the next step would be what? Cube root of x to the third. Is that correct? Tell your neighbor what number goes here in the red, please. X to the what? X to the second, x to the second. That is correct. So on top we have 5 cubed root of x to the second. And for the next step, we just simplify the denominator. 5 cubed root of x to the second over x. Hands, have you got that? Yeah. A multiplication one? Copy that one. There you go. No, we did one similar to that. In your dream? Yeah. Let's see if you can start it, please. Hurry up, hurry up. Copy that. Example 8, super cube. We got cube root of 216x to the 12y to the 15. All right. I guess we'll stop right there. Once again, home play for tonight, pages 552, 553, numbers 7 through 17 only. Good one, guys. Enjoy our home play. Make it a math family night. Gather around, people. Look what I learned. Tutoring today. See you guys later. Bye.